All right, so take a look. Let me read the prompt to you out loud to get you to see this again. To ensure a growing season of sufficient length, Mr. Hobson has at most 16 days. Basically, he has 16 days left to plant his corn and soybean crops. He can plant corn at a rate of 250 acres per day and soybeans at a rate of 200 acres per day. If he has at most 3,500 acres available, make a graph showing how many acres of each type of crops he can plant. Name one solution and explain what it means. Now, if you actually compare this to the prompt from yesterday, which is prompt 7, it shares some similar characteristics, being that asking for a solution, but you know that we can have multiple solutions for this. Is that true? I mean, we can certainly spend a couple of days planting soybeans and 1 day planting corn, or we can spend 0 day on either crops. We can have a lot of different answers, and we also need to filter out the answers that are mathematically correct but not reasonable. For example, can we plant -5 days of crops? Okay, can we plant 5.672879 point whatever, whatever day? Of course. So you gotta kind of look at your answer as overall and say which one is actually reasonable in the context of the problem. Notice I'm trying to give you a real life problem so that you can actually select a reasonable answer that applies to the problem itself. Now, if you read this problem carefully enough, unlike the problem from yesterday, we had only one limitation. Yesterday, what was the limitation on yesterday? What is it? Which is about weight, right? Okay, so the limitation from yesterday was just weight. Therefore, we came up with one inequality, we graphed that, and so be it. Look at this problem today, though. What kind of limitation do we have in this problem? Read carefully. Yes, Isaiah. Okay, so we have a limitation on land issue. We only have that much land to plant crops, 3,500 acres exactly to plant. We cannot go beyond that because we want to get our neighbors angry or anything, right? So we can certainly plant less than 3,500 acres if we want, but not more than that. Okay, what else is there that's kind of put a restriction on us? Yes, Ann? 16 days. Yeah. We don't just have land issue, we also have time issue, right? 16 days to plant both crops. I can plant 8 days here, 8 days there. That's a total of 16 days. I can plant 7 days here and 11 days. I can plant 0 and 0 days. I can plant 1 day, 2 days of the other one. It doesn't matter. But we do have 2 restrictions. Yesterday we had only 1. Today we have 2. So what does that mean in terms of the inequalities that we're going to have? Yes. Exactly. We have 2 inequalities today because we have 2 restrictions. So when you read a problem like this, always look at, just like when we've dealt with mixture problems, we look at overall how many things we have to deal with restriction, boundary. We have 1, it's just 1 equation. 2, we have 2 equations in this case. We have 2 restriction, therefore we are looking for to have 2 inequality to describe this. So if you analyze this problem overall, what is the one value here that's being changed, not staying fixed the whole time? Just like yesterday, we analyzed that the weight of the TV is fixed. It's 77 pounds. The weight of the microwave is 55 pounds. It's fixed. So we don't mess with that fixed number. What value in this problem is fixed? It's fixed, meaning it's not going to change throughout the problem. Yes?
3,500 acres.
Okay, first of all, we know that it's a boundary, right? Okay, what else is fixed in this problem? Yes? Be more specific than that. Yes. Okay, well, 16 days is also fixed. We know that too. Yes, what else is fixed?
The acres that you can plant for corn and soybeans.
Exactly. Look at the number of acres that you can plant per day for corn, per day for soybeans. Is this number actually fixed? 250 acres per day for corn, and 200 acres per day for soybeans, right? That's fixed. So that means if I plant 250 acres per day for corn, that means 2 days later I can plant 500 acres. 3 days later, that's 750. So you kind of see the math there. Similar to the weight problem yesterday. you know it's going to involve what here? What's involved here? It's involved multiplications, right? Okay. What multiplying what? What are we trying to find when we take 250 acres times 5 days? What are you trying to find there? Yes. Yeah, how much you can plant? Right, right. How many acres you can plant in that many days? But so in this case, what value can change over time? Yes, Mark.
The amount of days you plant.
The number of days that you spend planting. Is that true? The number of days. I can spend 2 days on corn, 3 days on corn, 4 days on corn. That can change over time. So because of that, what can we replace that with? When it's changing, what can we replace that with? A variable. So let's declare. How many variables should we have here? Two. Okay. So one variable to represent the day of planting corns, right? And the other variable to represent what? Yeah, days to plant soybeans. So I'm going to go ahead and declare two variables right now. X here represent the number of days planting corn. And of course, Y will be the numbers of days planting soybeans. Okay? There. So I have that information represented. Something that's changing, everything that's changing in the problem, I represent it using a variable, and I have that. So with this information, X represents the number of days planting corn, Y represents the number of days planting soybeans. What can I use those two variables to write? What can I actually come up with? Okay, so we talk about the limitations on time, which is days, limitation on acres, right? Using this, what can I write with? At this point. Okay, fine. Let's if you want to do that, go ahead. What can we say? 250 times x. That will represent what? What are we doing when we say 250 times x? Yes. X represents the number of days you plan. What is 250? Acres. So when you take 250 times x, what are you getting back? What are you calculating when you take 250 times x?
How many acres I covered?
Yeah, how much did you cover? How many acres did you cover, right? After this x number of days for corn. And now what about soybeans?
200.
Same thing. 200 times y. And what do you do with the 2? Okay. And it should be what? What's the restriction? Yeah. This is the amount of acres for corns, this amount of acres for soybeans, and they should be under what? Okay, how do I say that? It's going to be under, thank you, less than or equal. Okay, any question there? I got my first inequality. I know there's another one coming up. What should I write for the other one? So we're done with 3,500, that our limitation. We're done with that. What else have I not touched? The day. So how do I put x and y together and the number of days, 16 days? How do I put that into an inequality? X represents the number of days planting corns, y represents the number of days planting soybeans. I know I have a total of 60 days or less. So how do I equals
16.
Equals, so exactly 16 days? What does it say? At most 16 days.
Less than or equal to
Thank you.
16.
So x plus y less than or equal to 16. That makes sense, right? So if you actually read through your inequality, it will make sense. Watch. I have this many days to plant corns. I have this many days to plant soybeans. The total should be less than or equal to 16 days. Day. Acres, acres, acres. That's how you know your equation, or in this case, inequality is correct. Every unit has to match up. So we got ourselves two inequality, just like yesterday. We'll graph them, right? We can certainly graph. That's a pretty easy step. Next step anyway. So let's take a look at this first one. That should be easy to graph. Can you just look at that and tell me what the x-intercept and what the y-intercept are for this first inequality? What's the x-intercept here? What's the x-intercept? Yeah, I know. Y equals 0 if we want to find an x-intercept. So what is the x-intercept? Okay, 16. Do you see that? Of course, when we try to find the x-intercept, y is 0. This is simple because if this is going to go away, then x is simply going to be 16, right? So can we just say that for this x-intercept, it's going to be 16, 0? Simple equation to solve. And over here, what is it going to become? And the y-intercept here, of course, x will go away. Then it's going to be 0, 16. Question on how I obtain that first 2 points. So I'm going to use green points to represent that inequality. I'm going to use red points to represent my other inequalities. Let's find the x and y-intercept for the red one. For the x-intercept, what do I write? What will go away? The y. So that means, what do I have left? I know. Can you say it?
250.
250 x. We're solving for a point. Remember? No inequality needed. So just equal to 3,500, right? If I solve that, what do I get? 14. So can we just say that it's 14, 0? And for the y-intercept, what will go away? The x will go away. So that means I will have 200y equals to 3,500 divided by 200 both sides. Y will end up being what? 17 and a half. 17.5, or the point's going to be at 0, 17.5. Any questions so far on how to obtain my x-intercepts and y-intercepts for both? Go ahead. Question on that. We're good? So what do we do with the x and y-intercepts? We plot them in graphs. Very good. So I'm just going to go ahead and kind of, I need to make space here for this. So I'm just going to go ahead and kind of move this aside. Sorry. Okay, so I have that information. Let's graph that. Okay. For the green, I have 16, 0, 0, 16. So I'm just going to go ahead and skip this probably by 5. 5, 10, 15, 20. 5, 10, 15, and 20. So 16, 0 is probably going to be right here. And 0, 16 is right here. Question on that first 2 points. What line do I use? Solid or dotted? So, dotted or solid? Dotted, you said. Why?
Solid.
If it has equal, it's solid, right? Remember, just like close, solid, you got to make that connection already, right? Open means broken, dotted, okay? So in this case, both of them have equal part to your inequality, therefore it has to be solid lines. And I'm just going to go ahead and make that line going through the 2 points, and there I have my first graph. Are we done?
No.
No. What's the next step now after this? Let's shade it right now before we get confused with the other one. So once we graph one up, shade it right away. So which region should I test? The bottom. Okay, let's test the bottom region right here. And which point should I use to test? The 0, 0. So if I'm going to use 0, 0, I'm just going to have to go back here a little bit and try to show you what inequality I have. Remember this right here, right? If I plug in 0, 0 into the x plus y here, clearly you see that 0 plus 0 is 0, and 0 is definitely less than 16. Is that true? So we know that it is true. If it's true, where do we shade? The bottom. Okay? So I'm going to go ahead and show that right now, that this is the region where everything is true for that particular inequality. All right. Questions so far?
I like the teeth better.
Huh?
I like the teeth better. When
Okay.
it's
Here, let's graph the red inequality. We have 14, 0. Where's that going to be located? Which axis is that on? 14, 0. Okay, the x-axis. Okay, so it's going to be 14 is probably going to be right here, right? And the other one is 17.5, so it's slightly above the 16 mark, right there. Solid or dotted? solid again because of the equal part of the inequality. So I'm going to go ahead and try to be careful here and draw this particular line, and it's going to look like that. Okay, there you have it. Which region should I use to test? Okay, the bottom, fine, because there's an easy point in there, 0, 0, correct? So I'm going to use that 0, 0 and plug it right back into what I have here in the red inequality. But clearly, the reason I picked 0, 0 because it's so easy. Once you plug it in, it will turn the other one to 0, right? So 0 plus 0 is definitely less than 3,500. That's easy. So I know clearly that with the 0, it's going to be true where? In the bottom as well. So I use the red color and shade in the bottom part of the red line. Okay. I hope you start seeing stuff now. I've got to be careful not to overdo things. So, what do you see? What do you see here? Overlap. Thank you. They do overlap. What does it mean, overlap? What it means for, when you see overlapping graph, what it means is any point in the overlapping region will make both of your inequalities true. If you pick a point that is not in the overlap region, meaning this point right here, right? Let's say I pick a point right here. That point is true for which inequality, the red or the green?
Right.
But is it true for the green?
No.
No. See it? Because it's on the other side of green that it's false. So any point in the overlapping region will be true for both. You see what I'm saying? So when you have this case, you circle, or at least tell me that, hey, you see this part right here, that's the overlap? This is the solution, possible solution for not just one inequality, but for both at the same time. Since we have two inequalities, you got to represent that. Hey, this is a solution to both inequalities. And there you had it, the overlapping piece, and I highlighted, I even circled to show you that that would be the true solution. Now, if this is all possible solution to our problem, then does that mean that we can pick anything?
Yes.
Any points to make it reasonable answers? We talked about reasonable answer yesterday, right? Not every answer is reasonable because, yeah, for example, do we have negative, remember the x and y means number of days, right? Can we have negative days? Can we have 5.6759 days? You know, of course, we don't use that. You know, if you're going to be going to a farm and say, hey, I need you to go ahead and spend about 5.6789 days to plant corn, you think someone's going to get it?
If they do the math.
If they do the math, like right down to the minute, the second, and millisecond, and all that stuff, right? Yeah. But come on, it's a typical farm, you know? You just say, oh yeah, I want you to go and spend 5 days on this, okay? All right? Okay, so we'll talk about reasonable answers. And so when you give me the answers, explain what is considered to be reasonable in the context of the problem. Okay? This is not a scientific problem, so it's not okay for you to include negative and decimals in there, or fractions. It's too complex. Keep it simple for a simple problem. Okay, any questions so far on this one? Very similar to yesterday. We just have to do two at the same time. We're good? All right. If no other questions, I have another one to start with you. Oh, okay, here we go. So today, we're going to expand that knowledge a little bit more. And I want you, perhaps I already gave you this yesterday, but it's okay. What if today, I give you a graph like this? I know, I put it there. Let's say I have a graph like that. Okay, and I have the following. Negative 4/5 x plus 4. And this is the only information I can provide you with. That's it. What's missing? By the way, is this going to be an equation? No, why? It has shaded parts. Shaded means inequality, right? So we know that there is an inequality sign that's going to go into this box right here to make this inequality true. But observing, right? You're a scientist, and you're looking at this graph right here, and then you're going to use the process of elimination. Which two symbols can I actually eliminate before I even start the problem? We don't have to use all four, do we? We know there's only one symbol that will make this work. Which two symbols can I say not going to be good for this problem? What is it? Why did you say, I'm going to go ahead and eliminate this and this? Why? Very good. I look at the graph. This is a solid line. Solid has to do with the equal part to the inequality, right? This has to do with dotted. That doesn't go with solid. So therefore, I know these two won't work. Is that true? So I'm down to just this symbol or that symbol. And I figure out, okay, now how does this work? Which symbol will make this work? Well, first of all, did I not give you which side is true?
Bottom. The side.
Which side is true? The top or the bottom?
Top. Oh, I don't know. Top. Both.
Centina. Not a laughing matter. Why do you think I shade here? I shade means what? Shade means not true?
Oh, true.
Why do you have to shade? Because?
I don't know.
Why do I shade that region up on top? What does it mean?
So any other one will be right.
Yeah. That means if I pick any point in that region, it's going to be true,
I
right?
said that.
That's why you want to
Just
chop
right
it.
now. Just right now. I
Well,
said-
okay, good. Well, I realize. Okay, good.
Oh, I'm just slap
Now
it there.
So that means any point that I pick in here should be true to the inequality. Any point that I pick on this side should be false to the inequality. Is that true? I shouldn't mix it up. So any point that I pick on the other side of the shaded part should be false. Is that correct?
Yeah.
Okay. Now, remember I told you that you want to pick the easiest point to test? In this case, which region is available to test?
True.
Huh? Which region is available to test? Both. Not just the upper. Why am I saying that? We know that the upper is always true. That means any point we pick in here, we'll make it as true. If we happen to pick the bottom region, any point in here will make it false. So as long as we know where we pick to begin with, we can always force it. So let's say that, hey, because 0, 0 is easy to test, I still like 0, so I'm going to test that. 0, 0. I know that when I test this 0, 0, the answer, the result will have to be
Wrong.
false. So I know that whatever it is that I'm getting over here, it has to be false, right? If you like to pick the region up here, which is okay, I'll show you that case too. Watch what happens. Let's say I pick 0, 0. I plug 0 into y. I plug 0 into x. And this is what I have. 0 plus 4 is 4.
Right.
Okay, and here it is. 0 on the left side, 4 on the right hand side.
Zero
And I
on the
say, wait, let's go back. I picked 0, 0, and I know it's false. If it's false, which one will make this false? Okay, why is it false? Look at where the point is at. Which region is it in? It's in the one that's not shaded. Shaded, not unshaded means false, right? Is that true? All right, so therefore I go back here and say, if I know 0, 0 is false, I only plug it in and test it, how do I make it false again? The greater than sign. So that means, oh, by the way,
You can't use
an
that
equal,
one.
right? Yeah. So that means, that is the symbol I'm going to use for this particular inequality, because I pick a point and it's false, and I want to make this false. We're going backwards in a sense. Okay, we can choose region. Okay, let's say that I pick, instead of picking a false region, I pick a region here that's true. Right here. What point is that?
6.
3, 4, 5, 6. So it's going to be 0, 6, right? We clearly know that when I plug this in, it's going to be true. Correct?
Yeah.
So watch what happened. I'm going to plug in 0 for x, 6 for y. So here's 6, 0 for x, which will make this go away. It will go away, and then 4, right? Then now, because I want to make this true, correct? Which symbol will make it true? Or is it still the same as the red? So either way, I don't care which region you pick, as long as you know, is that region true or false to begin with. Then you make sure you match up with your inequality. If it's a false region you pick, it's going to be false at the end. If it's a true region you pick, it has to be true at the end. That's all we're doing. So I don't care which region it is. Questions at all on that one? So we're kind of going backwards a little bit. And beside that, I want to push for another thing. Your observation, please. Remember that for a line, any line for that matter, we need to have the slope. Is that true? Look at the slope. How did I all of a sudden look at this line and be able to come up with this information right away? Rise over run. Notice I actually don't even have to calculate that in my head. I just look at the graph. Look at this. Down 4, right 5. You see it? Down 4, right 5. That's how I got that -4 over 5. And where do you think I got that 4 from? Line of sight, right here. Be observant, guys. Even if I don't give you this information, you can still look at the graph and be able to pull that information from the graph. Okay, let's check out another one.
That was a. It's easy.
Here's the graph.
It's gonna be greater than less than.
Okay. This is all I'm giving you this time. Hey, no fair. Yeah. Okay. Now.
What about the numbers?
Very good, right? Very good. Good. Okay, good. I'm going to give you some more details on this one. This is -1, -2. This is 1, 2, 3, 4, 5, 6.
So you were lying.
Okay, there.
You said you wouldn't give us any more.
All right. I do need you to give the interval. Okay. Now look at this line. We know we have to make it into an inequality later, right? But to make it into an inequality, let's get the equation to represent the line first. Can you look at the line here and give me some information about the line? Look at it and give me some information about it. First of all, where does it cross over? Slope-wise, what is it about? Yeah, you go ahead. So. Huh? Well, that's later. That's later. I'm talking about look at some basic. Just like I notice, I did not give you anything to represent the line, right? To represent the line, you need the slope, the intercept, and all that stuff. Can you actually find that information from the graph?
Yeah.
Okay, what is the slope? Yes. Huh? Yeah, okay. Look at the graph. Yes. Slope is 3. How did you get that? Tell me, please. Tell me. How did you get 3? Huh? Go up 6. Okay. So you tell me to go 1, 2, 3, 4, 5, 6.
Yay, you can.
And 2 over. So up 6, 2 right.
What about 2? What?
So rise over run. 6 over 2 is 3. It's a positive because the line goes up. Makes sense. So at least at that point in time, I know my slope is 6. That information is given, right? Or for those of you who don't want to do that approach, and you want to do the subtraction approach, then just go and locate 2 points. Don't we have 2 points already? Look, what's this point at? What's this point? Location, please. -2, 0, right? So -2, 0. What about this one right here?
6.
0, 6. 0, 6. Watch what happened. Subtraction, subtraction. -2 minus 0 is -2. 0 minus 6 is -6. Rise over run. Y over x, right? So isn't it -6 over -2, which is also positive 3? Same thing.
That's crazy.
We did this before, people. Come on.
What chapter was that? Like chapter?
Oh, I'm
3,
sorry.
4?
3. My bad. Thank you for correcting that. There. So we can always find the slope of any line, for that matter, as long as you have 2 points on the line. And you know you can actually locate 2 points, at least, right? Locate the 2 easiest point you can find, and then find the slope. Either by rise over run technique, by looking at the graph, or plug it in and do a subtraction problem to find the slope. Now, if the line happens to have a y-intercept and it's easy to recognize, then use it. In this case, what is it crossing over?
6.
Crossing over where? 0, 6. So look, we have the slope, we have the y-intercept at 6. With that information, what can we come up with? Let's first write the equation before we think about inequality. Just get yourself a simple equation to represent the line. How do I take that information and write an equation? Yes? y equal mx plus b. Very good. Use that format. Okay. And
Plug in 3 into M.
okay, 3 into m and 6 into b. And there we have it. An equation to represent a line. We're not quite done because we need to finish up, turn it back into an inequality, right? So that's the easy case where you can look at the slope, you can look at the y-intercept. What if the y-intercept is not easily identified? Then what else can you do? Point slope form. Notice I'm pulling out all the stops right now to show you what you can actually do. Yeah, and you're right. Let's say that the y-intercept is not easily identified. Then the next step that you can actually do is this form. Remember this? The box form, the point slope form. And with the point slope form, it's actually another plug and chug kind of deal where you just plug it in. The slope is already there, which is 3. And this empty boxes, the y box and the x box, pick any point on the line. In this case, let's pick one. Let's say I pick 0 and -2, 0, right? So 0 to y and -2 to x, is that true? Right? What would happen when I solve? Y minus 0 equals to 3 times x minus -2. The y minus 0 is just simply going to be y. The x minus -2 is going to become x plus 2. So it's going to be 3x plus 2. I distribute, I add it with 3x plus 6, which is indeed the same thing as above. So it doesn't matter. But honestly, for the most cases, you'll see that the y-intercept is easily identifiable, so you can just go ahead and take it out. The slope is also easy to see. Rise over run technique, right? Okay. Any questions so far at this on this problem? Now, you would erase that equal and put in a box for it. You say, okay, now I need to turn it into an inequality problem. Which two symbol can I eliminate before we start? Okay, this is equal, so get rid of that. So that means I don't need to use this or this. Agree? Because this is clearly a dotted graph, not a solid. Now I go back and start testing. Which region is a good place to test?
That side.
Either way, it's fine, but in this case, the easiest point to test is where?
That side.
This side, and luckily for us, it's happened to be a true side as well. So that means if I know, if I'm going to be testing this point, 0, 0, I expect my answer to be? True. Correct, precisely. So look, I take 0, 0, I plug it right back into x and y. Let me just erase this to make some room here. Look what happened. 0 for y, 0 for x, oops. So that becomes 0 plus 0 plus 6 is 6, right? And we know that I expect this to be true. How do I make this true?
Less than.
Less than? Yeah, very good. And so, that will conclude it. Answer? Any questions? Please, I mean, it's okay to ask. We have a lot of time. Like 9 minutes. Okay?
9 minutes and
Yeah,
45 seconds.
Questions at all? So by now you know how to. Okay, all right. Let's test it.
Finish
I love
up
you guys.
again.
I love you.
9 minutes, 55 seconds.
Just make sure you know this.
56, 57,
Okay.
59,
Hey.
100.
All right. Let's see if you can give me the equation right on the slide just by looking. Okay, ready? Just looking at the graph.
72.
Santino, thanks. Appreciate it.
Put the numbers on there.
I will. I'm sorry.
Yes.
Tough crowd. This is a -3, and this is a 5. Okay, happy now? So you know at least it's skipping my 1. Every interval skipping my 1. Okay,
H.
the shaded part is this side. Okay, that's 1.
Oh, we can't write it down, huh?
Oh yeah, you can write it down now.
Oh, okay. We said just look at it.
Wow, like that. And shaded part is this side.
82.
Where's the overlapping region?
That one.
Just describe the direction. Just say that one. Like, where's that one?
The red and the black.
Yeah, on the right hand side. So there. Clearly, it's right here, right?
Over there.
Right here. That's where it overlapping occurs. Good. Okay, now I have your two graphs right here, shaded differently. I want you to come up with an inequality for each line. All right, let's start with the red. By looking at the red line, can you come up with an equation for that line right away? What? What's the slope? Yeah, very good.
-2.
It's actually right on the dot. I'm sorry. Yeah. What is it?
-2.
Negative 2/3. Very good. Negative 2/3. We're good. It's a line going down, rise over run, down 2, right 3. Easy enough.
Yeah.
What's the y-intercept?
+2.
Oh, +2. Oh, we're done with that one. Easy, right?
Yes.
What about the black one?
Wait, what is it 2?
Oh, come on.
Wait, wait, why'd you get 2?
Where did I get 2?
Yeah.
This is the y-intercept. Is that crossing over at 2?
Oh, yeah.
Yeah, that's why. Okay. Okay. What is the slope of that black one? 3/5. Positive, negative? Positive. So 3/5 x. And where is it crossing over at the on the y-axis? See how easy it is?
Yeah.
No. Who said no? Oh, Zuki, what happened? All right. So now that I have the equations, I can erase the equal sign. In place of that, I put a box, blank box, and you are trying to figure out which symbol should I put in there to make it true. So let's start. With the red line, it's solid. So what does that mean about the solid?
That it's less than equal to or
So there's an equal part to it, right?
Yeah.
So either this or this. Agree? What about the black one? Less than or greater than. Good. So let's set the black one. I'm sorry. The red one first. The red line. Red line.
Black people don't go.
Which region should we test?
That one.
Okay. Let's test the one that has 0, 0 in it, right? Like you said.
The black one.
So, if we pick that one to test, what answer do we expect to get back? False. So let's plug it in, test. 0, this will go away, so it's just going to be 2. Agree?
Yes.
Which symbol will make it false? Very good. So we're done with that one. Now go to the black line, black dotted line, and test. Which region would you like to test?
the top.
The top, yeah, it's easy too. But and we expect it to be what again?
False.
Which is false as well, right? So we expect both of them to be false. So let's test. I have a 0 right here. This will go away, and this is just a -3. Which symbol will make it false?
Less. Greater.
Like this?
Less.
Less than. So there it is. And we are done. Questions so far on how to do this? Is this easy enough?
Yeah.
Okay, let's wrap this up already. We're done. Thank you.